Okay, so this is from the review game that we did today. I just want to show how I would solve every single type of problem so that if you're stuck at home tonight, you can kind of just watch how this goes. So let's begin. The first problem that we had was simplify and name. And I can see, because it has adding, that I'm going to want to add these two things. Now when I do adding and subtracting, I like to stack them so I can see them in a nice even fashion. So I'm going to put this right here, and then I'm going to stack this just right beneath it. And then we're just going to add. So when I add straight down here, I'm going to get 11n squared. When I add straight down here, I'm going to get 3n. And when I add straight down here, I'm going to get 13. Now I have to name this thing. Because its highest degree is a 2, that's called a quadratic. And because it has 1, 2, 3 terms, it's called a trinomial. Let's try the next problem. So on this one, when I look, it is a subtraction problem. So we're going to subtract. But again, what I like to do is I like to stack these things. So I'm going to say 8x squared minus 3x plus 5. And underneath it, I'm going to put 3x squared plus 7x minus 2. And when I'm saying the pluses and minuses, I'm really thinking about these things being positive and negative instead of anything else. So 8 minus 3 will give me 5x squared. Negative 3 minus 7 will give me negative 10x. And then 5 minus a negative 2, well, when you subtract a negative, it actually adds. So this would be 7. And it would be a positive 7. So again, this appears to be the same thing. Its highest degree is 2. So it's a quadratic. And then I have 3 terms. So it is a trinomial. That's probably the most common polynomial that you get is a quadratic trinomial. We're going to do an entire unit on them eventually. Let's look at the next one. So in this one, what I can see is that I have this 4x squared, and we don't have an adding sign. They're like pressed up against each other, so this tells me it's multiplication or distribution. So I'm going to distribute this 4x squared. Well, 4 times 5 gives me 20, and then I just count up how many x's I have. I have 2 here and 3 here, so I have 5 x's. Notice when we multiply, we add the exponents, but when we add, just like in the last problem, we just get to combine the like terms. So that's going to give me 20x to the 5th. This will give me negative 30x to the 4th. And this will give me 28x squared. Okay? Let's try the next problem. Oh, let's stop for a second. Can I add these together? The answer would be no, because none of them are like terms. When I do this problem, again, I can see that they're pressed up against each other. So I can tell that this is multiplication. I'm going to multiply by distributing. And I'm going to distribute the 3n first, which is going to give me 18n squared plus 3n. Now, because I still have this 5 left over, I'm going to distribute the negative 5 and get negative 30n minus 5. And then I'm going to combine my like terms, because when I look across, both these things have n's. So I'm going to have 18n squared minus 27n minus 5. Let's try the next problem. So in this one, again, we can see that they're pressed up against each other, so that's multiplication. I'm going to multiply across the 2x, which will give me 14x to the 3rd minus 4x squared plus 10x. And now I'm going to multiply the 7 across. And I'm going to write it beneath because it's just hard for me to fit it on that space right there. So this is going to give me 49x squared minus 14x plus 35. And again, I'm going to combine like terms, so we can see that these both have x squareds and these both have x's. So I'm going to have 14x to the 3rd plus, I think that's a 45x squared minus 4x plus 35. And because there's nothing for me to combine, that would be my answer. Let's try the next problem. On this one, it's really tempting to square both things on the inside, but you can't do that because we have this adding in between. So when we have a squared and we have an adding, we have to rewrite it. So that means that we have 5x plus 4 times 5x plus 4. And now I can distribute it through. That's going to give me 25x squared plus 20x plus 20x plus 16, which in the end is going to give me 25x squared plus 40x, because I can combine my middle terms, plus 16. And this would be my final answer. Let's do the next one. Okay, so for this right here, again, you have this written out, so we're going to just distribute. When I distribute, I'm going to get 9n squared plus 21n minus 21n minus 49. Because these things are the same, they're going to cancel out. I'm going to be 9n squared minus 49. So when you distribute all those things, just make sure that you multiply the numbers and then you combined all your like terms after you've multiplied all your numbers. Let's do the next example. So now we're in the factoring case. And so when I factor, the first thing I always do is I look to see if I can divide anything out. And so when I look through here, it looks like I can divide out a 4 from each of these terms. So it's going to put a 4 in front. And then I'm going to get 2x to the 4th plus 5x to the 3rd minus 3x squared. And now I'm going to look how many x's these things share. So I can see that these things all share an x, and what you want to do is you want to take out x's until they don't all share an x. So I'm going to take out an x, and I'm going to get 4x, 2x3 plus 5x2 minus 3x. And you can see that they all still have one x, so I could take out a second one, which would give me 4x squared, 2x2 plus 5x minus 3. Now they don't all share an x, so I can't take any more x's. If you want to do this right away, because you go, oh look, they all share 2x's and they all share a 4, and take 4x squared out right off the bat, you can also do that. This is just kind of how I think about it in my head. Let's do another one. When I factor this, there's really nothing that's the same. So we're going to use our patterns that we know from before. I'm going to think what multiplies and what adds. So what multiplies to give me 28 is 7 and 4, but that wouldn't add to negative 11. But if I made them both negative, negative 7 and negative 4 would add to negative 11. So this would be the factors that I'm left with. Just remember that whenever we have a quadratic trinomial, we know from the patterns before that we have to multiply and add for the middle terms, and that will always work out. Okay, so for this one, as we kind of go through and kind of finish this up, you'll notice that we're factoring and we can't really divide anything out of here. So when I look at this, I got 2x squared, 13x, and 15, and there's just nothing I can divide out. So we also should notice that 15, there's no way to make 15 become 13. So this is one of those problems where you want to make a polynomial to make it easier on yourself. So take the 2 and times it by the 15. That's going to give you 30. And then we're going to think about what multiplies together to give us 30 and adds together to give us 13. Well, that would be 10 and 3. So now I'm going to rewrite my polynomial. 2x squared plus 10x plus 3x plus 15. And now that I have this, You might go, well, should I add these back together? No, because we just split them apart. So what we really want to do once we get to here is cut this thing in half and then factor out half and half at a time. So what we'll factor out of the front part is 2x, and I'll get x plus 5. We'll factor out this back part is 3, and I'll get x plus 5. And we can see that this is left over, and this is what's the same. So I'm going to get x plus 5 that I can factor out. And the stuff left over we always just put in the parentheses, so 2x plus 3. And this would be our final answer. So just make sure if you ever get the situation where you have a number in front and you can't divide it out, we need to make a polynomial to make it easier. Let's try the next one. And this one's a lot easier than it looks. There's only one thing that's going to work. It's going to be 2x times 2x, because 2x times 2x gives you 4. Then what multiplies together to give you 49? Well, that's easy. That's negative 7 and positive 7. And that would be the answer right there. Let's look at the next one. So the next one, this is the last problem we kind of see. And we want to find the area of the red. So if we want to find the area of the red, it's what I call a donut problem, where you want to find the area of the outside and lose this area in the middle. So if you think about making a donut, you might make an entire circle and then rip out the middle part. Well, like ripping out the middle part in math is subtraction. So we're going to find the area of the outside and then subtract it from the area of the inside. To find the area of the outside, we're going to multiply length times width, and we're going to end up getting x squared plus 9x plus 4x plus 36, which is going to give us x squared plus 13x plus 36. That's the area of the outside. Now we're going to do this over here and find the area of the inside, which will be x plus 5 times x plus 2. And again, we're going to get x squared plus 2x plus 5x plus 10. That combined is going to give me x squared plus 7x plus 10. And now, since we have the area of the outside and the area of the inside, we want to subtract out the area of the inside. Those will cancel. That's going to end up giving me 6x, and that's going to give me 26. This is the area. Now for this part they said, hey, by the way, the area is actually 56, so what is x? Well, then we would just have to say 6x plus 26 is equal to 56. Subtract 26 from both sides. We're going to get that 6x is equal to 30, which means that x is equal to 5. And that would be my final answer right there. If you have any questions on any part of this, please send me an email and let me know. And then make sure for the test tomorrow you're thinking through all the different elements of this.